Alright, hey guys, this is a video on functions. So essentially you can think of functions as like little mini programs that do very specific tasks usually. Um, you can use functions over and over again, so very reusable, and you can share your function library, kind of like this standard io.h. It's got printf in it, scanf. But you can share your own personal library, so if you want something that can sum up an array and give the average, which is what your programming assignment 2 is, you're going to have that little, lightweight statistics based library that will be ready for you to use whenever. And later on, I'll show you how you can separate it out into files and make it easy to transfer, however which way you want to do it, if you want to share it online or via email, stuff like that. All right, so let's start out with a really simple one. We know how to say hello in the main function, which is just printf hello, like so. Okay, I'm just going to run it, make sure my development environment's good. Okay, so we can create our own function that's not in the main, and we'll call it print hi, something like that. So when we go to define a function, we have to give its return type, the name of the function, and the input parameters, which is the stuff that goes inside of here. And then we open up the brackets and we define it. And if there's a return type, then we need to return a value. So let's start out with returning a return type called void. So with void, that means the function will not return anything back to whoever called it to run. But let's take a look at main real quick. Main has an int return type, and we're returning a value. With void, we don't need to return anything. So this one we're going to call print hello, but I'm not going to call it print hello. I'm going to say hello. This way you don't, try and correlate the word print with anything. This is just a function name that I came up with. It's not going to take any inputs for now, and I'm going to open up the brackets like we normally do. Normally in a function you're going to have some type of return, so I'll just go ahead and put this here anyway, but notice I didn't give it a value to return. So in this one we're going to say printf hello from the function. That way we can differentiate what gets printed out. Okay, so this looks just like int main, right? I mean, it's got the same structure. It's got a return type, a name, input parameters, and then you can return something, but if it's void, we're going to return nothing. So how do we call it? Well, remember, the program always starts from main. So when you go to call it, you can call it a main, or you can call a function with another function. But for now, let's just do it here. So we printf hello in the main, and then let's say hello, like so. We have the name of the function. Notice we don't need the return type when we actually call the function. No input parameters, and that should be good to go. So what I'm going to do is run this. It says hello, hello from the function. So this is the order it ran in. It said the program started at main, went to the next line, and then the first thing it hits is printf hello, which it does. Then the next line is say hello. It's calling the function say hello. So it goes from here and it finds it wherever it is in memory, and it begins running its code, which is this. It says hello from the function, prints it out, return. Where does it return? Wherever it was called, and it was called right here. So it returns to this line. And then the next thing the main runs is here. So essentially, you can pretend like this call, you can replace it with just this here. So you might be asking, well, why would you do that when you could have just put it right in here? Well, let's say I called say hello a bunch, right? And the only thing I wanted to change was take this exclamation point and put a period. Now, had I had a bunch of these, going through each one of these is kind of a pain to delete, delete, delete. Now we can just change it in one place, which is very convenient. So I'm going to run this, and sure enough, for each time I call it, it prints out hello from the function. It runs the say hello code over and over again. So now we have a very nice modular way of running tidbits of code, especially when we have to do it over and over again. Okay, so we're going to talk about input parameters now. Right now, say hello doesn't have any input parameters. Let's give it one. And we'll just pass in the value int. So we're going to pass in an integer. This is a local variable. And we'll just call it num. Doesn't matter. And I'm going to put in here, instead of all this, hello, you entered %d, and passing in the value num. Okay, so how do we translate? So basically this lets you pass information from one function to another. Because if I were to create int num here and set it to 7, but if I were to pass in a 9 down here, when this gets printed out, this will be 9. So I'm going to walk through this. Program starts at main. The main creates its own local variable called num. Local to main. The only function that knows about it right now is main. Prints out hello, and then say hello is called with an input parameter, that's an integer, of 9. So when this gets called, it comes up here. The 9 matches the type int, so everything is happy. Printf is called. Since this was 9 passed in, num has the value 9. Now this is a local variable to say hello. Main doesn't know what this is either. Only say hello knows what this is. Say hello sets this value to 9 because that's what's passed in. And then it gets printed out, return comes back to here, and then the program ends. So let's give that a try. Hello, you entered 9. That makes sense, right? So now, what's powerful with this is you can pass in variables as long as it's the same type. The name doesn't matter. So what I'm going to do is I'm actually going to change this to number blah blah, because I don't want you to associate num with this num. The naming convention for this name is only for say hello. It doesn't care what comes in as long as its value is an integer. So I'm going to take this name of the variable, which is local to main, number blah blah, and I'm going to pass it in to say hello. I'm going to run it. Hello, you entered 7. Cool. So now let's do one with multiple variables, or multiple inputs. So I'm going to comment this out. You don't need to delete this function if you're not going to use it right away. You have it, don't touch it. If you don't want it to run, you can just comment out the code. So this is what I'm going to do. I'm going to run it. Notice it only says hello. Even though I still have the function defined here, it was never called because it's commented out in the main. So let's create another one where it has a return type. So let's just create a function that will add two numbers together for us, and then return the sum back to the main so we can do something with it. So we'll call it adder, and it'll take in two integers. So here's the first one, separated by a comma, is the second one. Open up the brackets. So how do we add these two together? Well, we can do a couple of things. We can create a local variable called sum, and we can, do this, sum equals a plus b, oops, and then we can return sum. This is very clear, and we understand what's going on. But there's a shorthand version of this that you can do, especially if you can do everything in one line. You can get rid of all that, return and then just do a plus b. And that will return the sum of a plus b. See, we don't need to create a local variable and all that stuff, as long as we can return the value that we're looking for, which is the sum of a and b. Okay, so down here, I'm going to remove this, and I'm not even going to create two local variables in the main for a and b. Instead, I'm just going to straight up call this. So printf, we'll do %d plus %d equals %d. So for the first one, let's do 4. For the second one, let's do 6. And for the third one, let's call the function to do some work for us. So adder, we're going to call adder. Notice there's no return type here when we're calling the function. We open up the parentheses. Immediately Visual Studio tells us there's an int a and int b. That simply means we need two integers to go in here. And I chose 4 and 6 randomly. So for a, I want it to be 4. For b, I want it to be 6. And I'm going to close up the printf. So what's going to happen here, the program's going to start at main. It's going to run printf. And then when it gets to here, it's going to say, oh, I need to call this function to get this value. So I call this function with 4 and 6. So a will be represented as 4, or a will have the value 4, b will have the value 6 being passed in. Main has no clue what a and b is. It just knows that in the first slot I put 4, in the second slot I put 6. Now, when you define this, you had some sort of convention made up, and you're like, I'm just going to call this a, I'm just going to call this b, and then I'm just going to remember what to do with both of these. And what I wanted to do is take a and add it to b, and then return that value. And when this returns, it comes back to here. So this is as good as the value, putting the value 10. Except it ran this code before actually placing it here. So now I'm going to run it. And I should probably give it a new line. So 4 plus 6 equals 10. Pretty cool, right? Now this is hard-coded values. Let's create a couple of variables so I can get some input from the user. So I'll call this input 1 and input 2, and then I'm going to tell the user to enter in 2 integers, and we'll do scanf %d, and we'll store it into ampersand input 1, ampersand input 2. Okay, so now instead of putting 4 and 6 here, I can just put input 1, input 2, and input 1, input 2. Okay, so I'm going to run this, enter in 2 integers. We'll do 15 and 14. 15, 14, 29. Cool. Now we've created this little adder such that we'll never have to write a plus b again. Instead, we could do this. Well, you're like, that's way more letters. Why would I want to do that? Well, okay, let's make something a little bit more useful then. So I'm going to create something that returns a float. We're going to create the get average. So let's say get average of, let's do 2 numbers only. So we're going to do int a again, or let's do float a and float b. And so how do we compute the average? Well, it's simply a plus b divided by 2. So do that, and there's your get average for 2 numbers. Okay, so let's, right after this, we'll go printf average %f, because it's a float, and we're going to do, so this is something I haven't talked about yet. We're going to need to typecast. So when you get get average, open it up, it wants 2 floats. Right now our inputs are ints. Well, we can change them from ints to floats by doing this. open up a parentheses and type the word float, and then close parentheses. Then type the name of the variable that you'd like to change the type of. So we're casting that int type into a float type. And you have to match type to type when calling functions. So we'll do this. Okay. Now it should print out, once it gets the return value of the get average, it's going to print it out. And we'll keep it to 0.2 if there's going to be any. And notice I kept out these two. It's just going to compute. So it takes input 1 as an int and changes it to a float, because we define this first one as a float. And same with the second one. Input 2 will be float b. We sum them together and divide by 2 because that's the function, or the equation to get the average. So I'm going to run that. So let's see. Let's just do 15 and 15. So 15 plus 15 equals 30, and the average is obviously 15. So let's try 10 and 5. 7.5, that's the midpoint between 10 and 5. I agree with that. Okay? So now finally, passing in arrays to help you with your assignment. So when I gave you the assignment, let's say we'll do get average R, so you know this is going to be the one with the arrays. You're going to want to pass in type float arrays. So I know I'm going to pass in an array, so I'll just do this. When you go to create this local variable for get average R, you do not need to give it a value here. Just empty brackets. And the next thing you need is actually the size of the array. Now I'm just going to call it size. The reason you need to know, because if you'd like to go through every index of the array, you're going to need to know the size of the array, or else you don't know when to stop your for loop, right? So int I, and I'm going to do for I equals 0, I is less than size. This size is what's being used. I++, open that up. And for now, let me just print out each value of the array. So I'm going to print out the index and the value. And that's going to be a float. So we'll give it a new line. And this will be I, and this will be R, I. Okay, so now you might be asking, well, what do you mean I don't know the size? I wrote the program, and if I'm calling it in the main, you know, can't I just say something like, or just hard code this to like 4? Yeah, you could. You definitely could. But how useful is this in the future down the road to you? 4. Like, this function will only be able to get you the average of an array with 4 of size 4. What if you have an array of size 100? What if you have an array of size 1000? What if your array size changes every time a new user logs in or whatever? Something like that, right? You want this to be able to take any size of an array. And to be able to do that, as long as you pass the array in and how big it is, you can handle that. This code can handle any size array that it gets passed in, and right now it'll print it all out. It doesn't matter what size, as long as you pass that information in. So if you just change it to this function now can only print out arrays of size 4, or only the first 4 elements of the array. Or if you send in a 2-element array, this will actually probably crash when you run it. So that's another problem. Especially if you set this to 45 and your array is only like 10, this will crash. This will be a runtime error. So passing that in and thinking in generalities when creating your function is kind of the best way to go about creating your functions. you want to think about the future, and like maybe future coders or someone who takes your place or will be using your stuff will actually need it to be a lot more general, so it can be dynamic and very useful. So think about that when you're coding functions. You want it to be very general and take pretty much any size information. And to do that, you might need to pass in even more parameters to make sure you handle many cases. But for now in this class, you know, the array and the size is pretty much all you need. So continuing with this, with the average, let's just create a floating array here, and then we'll make it 10. And I'll give it some values. Let's see, 0, 1, 2, 3, 4, 5, 4, 3, 2, 1. Is that 10? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Okay. Alright, so right now getAverage, all it does is print out each element of the array. So let's just give it a try and see if it works. I'm gonna just remove these actually. Okay. And now I'm just going to call getAverage R, and we're going to pass it the array. I should probably rename this. I'll call this array main. That way, notice when you pass in an array to a function, all you need to give it is its name. That's it. No other brackets or anything like that. Now the size is 10. I just came up with that when I made this. Whatever. This should also return a value because it has a return type of float. So let's return a float. I'm going to do that. You can probably just use 0. Alright, so I'm going to run it. And sure enough, prints everything out. Starts with the main, creates the array main array, and initializes it. And then I call the getAverage array. And I pass in the array main, give it size 10. So this R's array main doesn't, remember getAverage R, this function doesn't care what main named it, this is what it's going to name it. And then size is going to get the value 10. So size is used here, and the RI is printed out here. Like so. Okay, so now let's do the maths. So in order to add up each element of the array, we can use a for loop. First I'm going to create a sum variable and initialize it to 0. So I want to take the current sum and add it to the element of the array. Sum starts off at 0 when I is 0. So we want to take that and store that value, 0 plus the very first element, which happens to be 0 as well, and store that back into sum. So now when I equals 1, sum will have its previous sum. This will be the previous sum, and then you add it to the next index. And then you store that here, updating sum. So remember, the stuff on the right happens first, then it stores the value to the left. So now instead of returning 0.0, let's return the sum for now. So I'm going to run this, and nothing happens, or nothing is shown. Something happens. But notice, I don't have a printf or anything, it's not printing this value. So let me show you an example. We're going to, returns a float, and I'm going to call this return values, because we'll use it for all the return value stuff. So I'm going to put return values here. Whatever getAverage array returns, I want to store it here, and then I want to print it. So printf, the return value equals, and then %f, I'll use 0.2, and throw a new line in there, and print out the value of return values, not getAverage R. I'm not calling the value here. Instead, I just saved the value that it returned, so I can call it once and save and reuse this whenever. So I don't have to keep calling it. I can just save it into a variable. So I'm going to run it. My return value is 25. Does that make sense? Let's see. Let's see, 8, 6, that's 14, plus 4, that's 18, plus 2, that's 20, and plus 5 is 25. So that makes sense. Oh, that's an old one. And that's an old one too. Okay. You're right. 25. Okay, cool. So we successfully calculate the sum here. So this calculates sum. Now, to calculate the average, we just need to divide it by the size of the array. So I can just go to the return and do this, sum divided by size. So now, when I run it, it should give me the average value, which is 2.0 apparently. Let's check that. Okay, so with that website that I gave you guys on Programming Assignment 1, I entered in the stuff, and the average is 2.5. So what's the deal with that? Let's find out. Alright, let's see. Close this, close this. The first things I check is type. Type is usually an issue. So float return values, that's what we need. We're passing in floats. Okay, that looks good. That's the size 10. Okay, that's interesting. So remember 10, this will come in as an int. See right here, it's going to be stored as an int. So int, right here. So when we add floats together, we definitely want to store it into floating type variables. So when the sum does its thing here, yeah. Okay, so now let's give it a try. There it is, 2.5. Now, we have a floating point here and an int here. Usually takes on the size of sometimes int versus float. So what I like to do is to actually just typecast anything that I might not be too sure about. Because this is now a convention for like per compiler. So this could change based on what compiler you're using and even the language. So just to be safe, I'll do this, and of course I get the same answer. So you can cast your int into a float, so you have float divided by float. Okay. And the last thing I talked about was local versus global variables. Right now, everything you're creating is local here and local here. You know, the local variables are only known to the function that they belong to. And in order to pass information between two functions are stuff like input parameters, like so. You define it to take input parameters, and you feed them data through their input parameters, right? Okay, so I also talked about the idea of global variables. So let's just say int global number, and you don't need to use the word global, you can call it whatever you want. I'll make it 5. Okay, so if I were to do, so going back to here, deleting all this, if I were to printf %d new line and give it global number. Now, let me delete this for a second. When deleted, it says identifier global number is undefined. But when I put it back, it's happy. So what happened was it looked for a local variable first. It's looking for a local variable. If it's not there, then it's going to check global variables on the outside of the main function. Not in other functions, but just in general on the outside. Kind of like how these functions are on the outside of the main function. If it's there, then it's happy. You run it, you get 5. But now, let's do this. Let's create a local variable called global number and set it to 7. Now here's the rule. It's going to check its local variables first. Then it'll check the global variable. So I'm going to run it. So there it is, 7. This global variable did not mean this one, but it meant this one because it said, we created a local variable called global number. Let's use that. But if it's gone, it's going to say, did we create one? No. But we do have one here. Let's use that. I'm going to save it, run it. Sure enough, there it is. So that means I can use global number in here. And then I'm going to call this plus global. So I'm going to take A plus B, and then I'm going to add whatever the global number is. See, notice I didn't need to pass in global number at all. It just knows about it because there's no local one. So it went and checked to see if there was a global. And sure enough, there it is. So now I'm going to call adder plus global. I'm going to pass in 4, 7. That's it. That's all you need to pass, because when I go here, there's only 2 defined. So you only give it 2. And what it's going to do is going to say 4 plus 7 is 11. Where is it? 4 plus 7 is 11. Plus the global number is 11 plus 5, which is 16. So it should print out 16. And sure enough, it does. Okay, so that's essentially what you can use. You can use global variables to help keep track of the state of the program. So if it's in the first state, the last state, the second state, the waiting state, kind of like with the football analogy I gave. If it's a game, whose turn is it? You can keep track of that. You can keep track of how many, you can keep track of counting stuff, so how many turns were made, etc., things like that. A running score, a running statistic, you can make that global. Okay, so now let's just make the prototypes. So what I'm going to do is I'm going to copy all these functions. I'm going to copy them. Actually, I'm going to cut them. No, I'm going to copy them. I'm going to copy them, sorry. And I'm going to paste them underneath main. I'm going to save that. And now I'm going to create what's called the prototype. Basically, I'm going to delete all the code block and replace it with a semicolon. This is kind of just like declaring a variable without giving it a value. You're saying, we're going to use this eventually, so I'm going to create it now. And that's what I'm doing here. We're going to use these functions eventually, but I'm going to create them now. So what this allows you to do is to write neater code, actually. And it actually preps you to move to multiple files. So right now, I've got 4 functions here. This is what your programming assignment looks like. If you haven't done anything yet, this is what it looks like. And what you're going to want to do is define these functions as explained throughout this entire video. So I'm going to just actually take these out. I'm going to go a step further, and I'm going to remove all of this. Now I'm going to create a new file called a header. Add new item, and then it's not a CPP file, but a .h file. And I'm going to call this my functions. You can call it whatever you'd like. I'm going to capital M. There we go. My functions. I'm going to click add. I'm going to double click it. I'm going to paste my fully defined functions here. Now notice printf is red squiggly, global number has a red squiggly. We need to actually do the pound include standard io.h in order to solve that problem. And for global number, we'll take this out for now. I'll save that for another time. We'll just turn it back to adder. And I'm going to save this, okay? And we only know it as adder now. But now, so it says adder is undefined. Well, that's because we didn't tell it to, what file or what library we can find adder in. Well, we can find adder inside of, so pound include. Now, not these things. Use quotation marks, and it pops up for me my functions.h, and then close, and I'm going to save it, and then see it knows about adder now. Look how clean this looks, totally empty. While all your functions are over here, separated, and you can work on them separately from the main. So I'm going to run this, and sure enough, 4 plus 7 is 11. What other functions do I have? I can get the average of those two numbers. So I can do %f, and then call get average, and it needs two floats, so I'm just gonna do 4.0 and 7.0. Okay, let's give that a try. 11 and 5.5. Pretty cool, right? So now these are like printf and scanf. You don't see the definition, but you use the library that they're in. Alright, so I hope that helps. We'll be talking about this more next week. And yeah, good luck.